this movie, I'm going to consider the elevation of the coordinate systems that we have here in our Revit project. So far, in most of the previous movies, we've addressed only the horizontal and vertical axes, or the north-south direction and the east-west direction, which would be sometimes referred to as the X and Y axes in a standard Cartesian coordinate system. But what about the Z-axis, or what Revit terms the elevation? That's what we're going to look at here. Now, in the file that I have on screen, I've got the site plan active, and I've got both the project base point and survey points visible on screen. Now, in the previous movie, we used the specify coordinates at a point command to indicate exactly where we wanted the survey point to go. And I even drew this model line here to snap directly to that location. Now, I'm going to keep that model line because it will be handy to help us as we move the survey point to remember where this location was. Now, there's a few ways we could get the coordinates of that point just for reference. We can go to the Manage tab, and under Coordinates, there's a command here called Report Shared Coordinates. And this will allow you to click right at a point on screen, in this case, the end of that model line, and you'll see the coordinates reported here on the options bar. And you can see that those are the numbers that we input in the previous movie. Now, of course, if I cancel out of that command and select the survey point, you're going to see those same values displayed directly on the survey point as well. And we could also use on the Annotate tab a spot coordinate, and we could click right at that point and place a spot coordinate. Now, the default spot coordinate shows only the horizontal and vertical axes. So if you select that coordinate symbol and on the Properties palette, open up the Type selector, you can choose the one that says horizontal with elevations, and it will add the third dimension into that symbol. So now we can see that there's 3 different ways which we can report the value at the endpoint of that model line. Now I'm going to leave this symbol here and the model line here, and I'm going to select the survey point. You'll notice that it's currently unclipped, and that's important because if it's clipped, 2 things. 1, you can't change the dimensions directly in the point, and 2, if you were to actually move it, what would happen is, notice there in the background on that spot annotation symbol that I'm actually moving the 0, 0 point. And if I were to let go, this point would still report the same values that it did a moment ago. The only thing is, it would change the values that you see here in the spot coordinate because the endpoint of this model line relative to the new location of 0, 0 is now at a different spot. That's important. So I'm going to undo, and I want to make sure that this is unclicked. That's the only way to ensure that you're not actually moving 0, 0 when you move this survey point. So now I could move it the same way that I started to a moment ago by dragging it around, but that's not very precise. So what I'm going to do instead is I'm going to click right in each of the values, starting with north-south, and I'm going to type 0. Now when I enter that, it will go off screen. So I'm going to do ZF to zoom to fit, and you can see it down there at the bottom of the screen. Now I'm going to click in the east-west field, set that to 0, and then finally the elevation field, and also set that to 0. Now, we can tell now exactly where 0, 0 is. The survey point is at that location, but we're really not getting a good sense of what's actually going on with the elevation, or the height in this case. Now, let me zoom back over here and just remind you that we've left this model line unchanged. So it's still at the location that the survey point was previously at. In order to understand what we've done vertically, I'm going to create a new view that allows me to look at the elevation. You really can't visualize what's going on with the elevation in a floor plan. So we need either an elevation or a section. Now, none of the elevations that I currently have will really do the job. It's possible that I could use the north elevation because it is looking in the general direction of this symbol, but it would be reversed on screen. So I think it would be a little bit easier to understand if I just simply create a section and I'll run it across the bottom here like so. Now I want the depth of the section to be deep enough to see the entire model, so I'll go ahead and stretch it like that. And then I'm going to deselect it, double click the section head to open that view. Now you could next take these grips and resize the crop region to see more. But what I actually want to do is just turn off the crop region altogether. So down here on the view control bar, I'm going to click the do not crop view. And now the view is not cropped at all. Now, we're not seeing the project base point or the survey point in the section view. Because it's something we control with visibility graphics, each view has its own settings. So I'll just simply go to VG, scroll down, locate the site component, expand it, and I'll turn on both the project base point and the survey point. And when you click OK, now you will see very clearly that our survey point is actually 122 feet below the location of that model line that we have up there at level 1. So that's a very clear way to kind of see and understand what's going on vertically with the Z direction. Now, I can leave the model line there as a marker for that fire hydrant or that manhole cover that we're using as sort of a benchmark in our project. I could move the survey point back to that location and perhaps put another object down here to mark 00, like another model line or even another object that I've created. Anything is possible in those locations. Or if you don't really need to actually mark the 00, then you can simply move the survey point back to where it was. The choice is really up to you. But this is a good way of visualizing both the 00 location and the location of where the survey point previously was, which we were saying was meaningful within our project. Now let me show you one other thing that's going to be helpful in terms of the Z elevations. So let me zoom in here on the level heads of this project. And at the moment, you'll see that level 1 is at 0 and level 2 is at 10. Now, if you select the level head and go to the Edit Type button here on Properties, what you'll see is that the elevation base can be measured from one of two possibilities. It can either be measured from the project base point or from the survey point. So at the moment, you can see here in the background that my project base point is sitting right coincident with level 1. And that is why we're seeing the value of 0 right here. But we also know that our survey point is currently 122 feet below that. So if I change the elevation base to survey point and click OK, notice the results of both of these levels. So you can actually measure the levels in your project from either location. And some projects, they like to actually measure the heights of the levels from sea level. And this can be the way that you do that. So don't consider just the X and Y directions when you're setting up your survey point and your project base point. Consider also the Z or the elevation parameter. And by setting the location of that point in a very precise location in all three directions, then you gain a great deal of control over how you are measuring the various values throughout your project. In this chapter, we're going to take a lot of the concepts that we've covered in the previous chapter and kind of tie them together into a very simple sort of real-life scenario. So probably the simplest scenario that involves setting up coordinates is bringing a single building onto a single site. So just to kind of summarize what we did in the previous chapter, we talked about an overall coordinate system, which is like this curved grid that you see here. And that coordinate system has a north direction, which we call true north. It also has an origin, and you can put your survey point at that origin or at any point along the grid. And then the project has its own internal coordinate system that either aligns with and it coincides with this coordinate system that we have here, or it can actually be shifted and rotated from that. And so here I'm showing it shifted and rotated just for contrast, but it has its own project north and its own project orientation X, Y, and Z as related back to the original grid. So when it comes time to set up a project, I like to think of this overall coordinate system as being sort of the world at large. Okay, so that's typically your site. So whatever information you get from your civil engineer, you would relate back to that. And then placing your building on that site, your building itself becomes the project coordinate system, and it kind of sits on that site and you kind of position it where you want it to go. So back here in Revit, I've got a really simple file that just contains a topo surface, and we're going to place a simple building directly on this topo surface. So we're going to just link that in using the link Revit command here on the Insert tab. Now I'm going to select my building file, and as you can see, it's just a simple shed here. And down here at the bottom, there's some positioning options, and there are three at the top labeled auto center to center, origin to origin, and by shared coordinates. Now, a lot of times you'd be tempted to use origin to origin, and in many buildings that is the appropriate choice, particularly when you're assembling different parts of the same building. For example, if you have an architectural model and an MEP model and a structural model, there's a pretty good chance that all of those models will share the same origin. Therefore, the easiest choice is to just use origin to origin. Now, I've got an example of this in the Up and Running with Revit course here in the lynda.com library. So you're welcome to go through the steps there if you'd like to see an example of that. And you'll bring in an MEP model and insert it into an architectural model. By shared coordinates is ultimately the choice that we're going to want to use here in the lessons that follow. But before we can use that, we have to actually set it up. So the first time you bring in a linked file, you can't choose by shared coordinates because the site and the building don't yet share any coordinates. And the whole concept of shared coordinates is quite simply that you're going to make the coordinate systems of those two files match one another. But we have to set that up first. So in this case, I'm going to choose center to center. Now, all center to center does is just drop the building in the middle of the screen somewhere. And it makes it convenient so that you can actually see what you're working with. If I chose origin to origin, it might go off screen because the origins might be so far apart from one another that I wouldn't even see the file and I'd have to go hunt for it. So in this case, it just sort of guarantees that I'll get some kind of result on the screen. So I always like to start with center to center when my intention is to set up shared coordinates. Now, the next thing is to actually select the building and position it where it needs to go on the site. Now, you can do this very precisely by getting information from your civil engineer. You may recall that we've got our base point located over here. This is our survey point right here. We've got our project base point, which we're going to ultimately move, but at the moment it's sitting in this location. And we could use either of those to help us position the building, or you could just simply move it based on any other item on the screen. Now, this is a very simple site file. It doesn't have any roads or any parking or anything like that. But in many cases, you will have those kinds of elements in your site file, and you can just simply move relative to them. In this case, we could just pick it up and move it. That's a little imprecise. Or we could actually use the move command and our object snaps and move it more precisely. Like, for example, I could actually snap it right to the location where I previously put that project base point, if that's meaningful. Or perhaps I'd actually been instructed that it needs to move over in this direction, and I'll just go 30 units. And it needs to move up a little bit, and I'm just going to go 15 units. And then perhaps it even needs to be rotated a little bit. Let's just do maybe about 10 degrees, okay, to kind of get it to follow these soft, gentle contours right here. Now, once I've got it positioned in the location that's appropriate for the project, then I can actually come back and select my project base point and move it as well. So I'm just going to grab it and drag it. Notice that I have it unclipped, so the coordinates are actually updating in real time. You can kind of see them changing as I drag this to match the new location on the screen. So that's kind of important because remember from previous movies, if we have it clipped, it will actually move the project. Okay, so we don't want it to move the project in this case. We simply want to snap it to the location of the building so that it's a little bit more meaningful. So I've put it down there at the lower left-hand corner of the building itself. Now, at this point, if you wanted to, you could clip it to keep it attached at that location, or you could leave it unclipped. That's entirely up to you. So at this point, we have our linked file, and we could actually leave it like this. This is all we really need to do. And if the building file changes, we just simply update the link, and it would update right in the correct location. If you want to take it a little bit further and create a cross-reference relationship between the two files so that you can actually open up the building file and link in the site to the correct location, then what you want is actually shared coordinates. And that will be the subject of the next few movies. In this movie, we're going to save shared coordinates for two linked files. So in the host file that I'm in, we have a simple topo surface. And then linked into that file, we have this very small little shed building here, which has been linked into the file. Now, previously, I moved it and rotated it and positioned it where I wanted it to go on the site. That was the subject of the previous movie. What we're going to do in this movie is we're going to save all of those transformations, the moves and the rotates, and give that a name. And Once we've given that a name, that saved location is going to be something that we can then replicate in other files. We call that saving shared coordinates. So let's go ahead and look at the process here. So I'm going to select the linked file directly on screen. Over here in the Properties palette, you'll see something called Shared Site. And then next to that is a button labeled Not Shared. You can click that button to display the Share Coordinates dialog. So we have two options here. We can either publish or acquire our coordinates. Now, it's essentially which direction you want the save to go. With publish, you're taking the coordinates from the current host file, which is my shared coordinate file, the one that contains my topography in this case, and making that information pushed out to the linked files. Or you can do the opposite. You can say acquire, which would mean that I would be reading any information from that linked shed building and pulling it into the host file. Now, for a project like this where you have just two files linked together, you honestly could choose either one and get virtually the same result. What I like to do is I always like the site file, the file that contains the topography, this file that contains the parking lots and the roads, the overall building site information. I always like that to become the file that my coordinates come from. So if I'm in that file, such as I am right now, I will publish from it to the buildings. If I'm in a building file, then I will acquire from my site file, but I always want it to go from my site file to the buildings. So in this case, since I'm in my site file, I'm going to publish to my building. So I'm going to leave that option checked. Now down here, it says record the selected instance as being at position, and then it's suggesting the name building S, which is the name of that linked file, internal. Now, I'm going to click the change button here, and this next step is actually optional, but I like to either rename or duplicate internal. Internal is the default name that Revit gives to the saved location. Now, this dialog is called the location, weather, and site, and we're on the site tab. And so what we're actually doing is saving what Revit calls a saved site. And a site is nothing more than all of the site information for a particular instance of a linked file recorded for reuse later. So in this case, we're saying this little shed building, we're going to record the information about where it lives on the site in whatever we name it here. So I'm going to duplicate internal, and I'm going to call this shed building. Now, the name you choose isn't so important as the idea of actually going ahead and giving it a name. When I do that and I click OK, it will display that name here. And it's a way that I can kind of remember that I've set this up. Okay, if it still says internal, then I'm not completely sure. So that's just a little process that I go through to kind of remind myself that I've already set this up. I'll click this reconcile button here. And now you'll see that the shared site is shed building. Now, if I'd left it internal, it might not be quite as descriptive. Shared site is internal. So that's the other reason I like to give it a descriptive name. Okay, all that remains now is to save the file. So I'm just simply going to save the file. I'm going to click the icon here, or you can do Control S. And then you'll see a dialog that displays that says the location position changed. And what they're talking about is that position that we named here for the linked building. In other words, we're actually going to be saving to the file called building S. So we're saving both files here. This is the right answer, save. If you choose do not save, it's like the same as clicking cancel. And disabling shared position is kind of the same thing too, because it'll just turn off all the work that you've just done. So really these two options are not good options. You want to click save. Now once you've done that, it will actually save over both files. So now both files have been updated and saved, and we've now saved shared coordinates. And again, to remind you where you see that, it will show up here. And the other place that you'll see it is if you go to the Insert tab and click Manage Links. So when you click Manage Links, there is an indication of saved positions here in this dialog. It's a little more subtle. Positions not saved is kind of like an alert to let you know that you haven't yet saved that information. Had I come into this dialog before clicking the Save button, there would have been a checkbox here. But now that I've actually saved that, you can see that it's unchecked. So it's a little bit more subtle, but you can actually get some indication that you've got saved coordinates right there in the Manage Links dialog. So to save coordinates is as simple as selecting the file and on properties, going in and either publishing or acquiring the saved coordinate system that you want to use, and then giving it a name in the Save Positions dialog. In this movie, we're going to talk about what I call cross-linking. Now, cross-linking is quite simply reversing the relationship that we have between the two linked files. So at the moment, I'm in a file called crosslink, and it contains this topographic surface. And linked into this file is this small shed building here, which, if I select it, has a shared site called shed building. Now, all of these steps we performed in the last few movies. Now, what I'd like to do is open the shed building and link into it the terrain model here and use that for cross coordination. Now, Revit doesn't allow us to have both files open at the same time if they're linked to one another. So if they're not linked, it's no problem. You can have multiple projects. But when they're linked to one another, Revit doesn't like to have them both open at the same time in the same copy of Revit. So what I'm going to do first is go to my application menu, the big R here, and choose close. And that will close the file called crosslink. Then I'm going to go to open, and I'm going to choose building X. And this is the shed itself. And I'll just open that building. So as you can see, when the building opens, I'm just looking at the first floor plan of that small shed. And notice that the orientation of this building is horizontal. Okay, so when we view this building, it is set to its Project North orientation. And in its Project North orientation, the building geometry is perpendicular and parallel to the screen, which is more convenient to work on that file. Now, if I went to the site plan in this file, what you're going to see is the project base point and the survey point are both turned on here, as is typical in site plans, and they're already positioned with the same offset away from one another that we saw in the previous file. Now, where this comes from is the fact that when we saved our shared coordinates, Revit actually replaces the coordinate system of the file you're publishing to with the file that you're publishing from. So that's what we mean by shared coordinates. It literally replaces that coordinate system and records the location that your building has within that larger coordinate system. So if I select the survey point here, you can see that that's actually the 0, point. But notice the small change in orientation right there. That's simply because the building is actually slightly rotated on the site, and this reflects the understanding of that rotation. And if I select the project base point over here, you'll see that its axes are vertical and horizontal, matching the orientation of the building itself. Now, the angle to true north is recorded right here as 10 degrees, and so that's reflected in the slight angle of those two axes right there. Now, notice here that it says the survey point is internal. Well, if we click right on that little link there, that's the same as going to manage and opening up the location, weather, and site dialog and clicking the site tab. And notice that the two locations are here in this file. Internal, which was the default one, was already there, and shed building, the one that we saved when we set up the shared coordinates. Now you can actually make either of these current. Now in this case, you may recall that we actually did duplicate, so they're really both the same. So technically, we don't need internal anymore. We could delete it, but I'm going to leave it there just in case, and I'm going to make the shed building current, and I'll click OK. Now, sometimes in order to refresh this, you just need to click away from it and then select it again. And as you can see, it now correctly shows that the shed building is the active location. Okay, so now that we understand that the shared coordinates actually exist here, they're represented here in this file, and we're just simply seeing the project orientation of this file. Now what I'd like to do is actually cross-link the site plan into this model file. Once you've got shared coordinates, it's very easy to do that. You simply go to Insert, you click the Link Revit button, you select your site plan, and the only thing that we're going to do differently here is for positioning, we're now going to choose by shared coordinates. And the file will know that these two files share the same coordinate system, so that when I open this, that file will come in exactly the correct location with respect to the coordinate system. Now notice that this file is at a slight angle. It's at an angle to compensate for the fact that we're currently viewing from the perspective of the building. So when you think about it, whatever file you're in, it gives you its relative perspective. So the site file has to be rotated -10 degrees in order to compensate for the fact that the building was actually rotated +10 degrees on the site. And Revit does this for us automatically. And that's really the beauty of setting up shared coordinates. So it's a really simple process to do, but by doing it, you can now link and then cross-link the two files to one another and have them know exactly where to go with respect to each other. In the previous chapter, we looked at setting up a single collection of files, one site, one building, cross-referenced to one another. In this chapter, we're going to look at what happens when you have more than one building on the same site. So I'm in a file that has a really simple terrain model, and I'm looking at it currently in elevation. So I'm in a view called South Cropped, and you can see that I'm seeing just a portion of the building elevation. I've got 3 levels here, and I've labeled each one platform 1, 2, and 3, and those will be the locations of the heights of each of the buildings. So you can see that each building is going to sit at a slightly different height from its neighbors. And then I've carved out these little platforms here in the terrain to receive each of the buildings. The buildings are just representational in this example, as you'll see when we link in the first one. So let me go to a site plan. I'm going to go to the site Project North. I also have a True North one if you want to take a look at that. And as you can see at the moment, both the survey and project base points are right in the middle of the screen. Now I've got these grid lines here just to help me in positioning the 3 buildings as I bring them in. So I'll go to Insert, and I'll go to Link Revit, and I'll select the first one called Building A. Now, as we saw in the previous chapter, I can't yet do my shared coordinates. If I try to, it will tell me that there are no shared coordinate systems between these 2 files, and so it's just going to go to the default center to center anyway. So even if you don't choose center to center, if you try to go by shared coordinates and they haven't been set up yet, it will use center to center for you. And you briefly saw the file appear, but then it kind of disappears. Well, the reason for that is it's actually much lower than this topo surface. So at a moment ago, we were actually in the view called South Cropped. But if I go to the view called South Full, you can kind of see the problem. This terrain model is actually quite deep. And here is the linked file, which is actually below grade at this point. So I wanted you to see what would happen in that situation because we've already talked about in previous movies how the shared coordinate system isn't just X and Y, it's X, Y, and Z. So keep that in mind. If you link in a file and it goes missing, it may very well be that it's just too low or too high. So you can go to an elevation or section view, turn off the cropping, and locate the file that way and move it. So let's start by moving it in the Z direction then. So this is going to be the building we're going to put over here on platform 1. So I'm going to go to Modify, click the Align command. I'll highlight platform 1 as my alignment edge, and then I'll come down here and highlight level 1 to move it up. And to keep our building straight, I've just simply put letters in them so that we can very clearly know which one is which. So that is building A. Now, to align it in the other directions, I need to return to my site plan. So I'll go to Project North, click on my Align tool again, and I'll line up Grid 1, and Grid 1, and Grid A, and Grid A. And so if we take a look back in either of my south elevations, you can now see that building has been positioned properly on its platform. So I can repeat the process for buildings B and C and any other buildings that I have. Now, since our intention is to build this right away with shared coordinates, then as we saw in the previous chapter, the next thing you might want to do with this linked file is to actually select it and set up your shared coordinates. Now, it's going to be exactly the same process that we did in the previous chapter, so I'll just quickly review here. Because I'm working in the site file, I'm going to publish from the site file to building A. And then furthermore, I'm going to click the change button because I always prefer to do this as I mentioned there. And this time, instead of duplicating internal, just to make it cleaner, I'm actually going to rename internal and call this platform 1. Now, I'm just using platform 1 because that's where we cited it in the previous step. I'll click OK, reconcile it, and then save the file. When I do, it'll ask me to save the linked file as well. And now I can repeat the process to add the other two buildings. So I'll go ahead and set up the other two files, and then we'll just simply skip ahead for the next step. But these two buildings already have the shared coordinates set up, so they already know about the platform 2 and 3 locations. So the process will be slightly different than what we did for building A. So if I go to Link Revit, I'm going to choose building I in this case, and I'll choose by shared coordinates. When I click open, it will display the location weather and site dialog. Go right to the site tab and notice that it's actually giving me two choices of site. And here is platform 2, which is this location right here in the middle. It's already been pre-saved, so when I click OK, building I will know exactly where to go. And I can repeat the same process for building M by shared coordinates. And this time I'll get two choices, platform 1 or platform 3. So in this case, I'll choose platform 3 and click OK. So that gives us our three buildings on the site. Now they inadvertently spelled the word aim, but that's not really so important to the end result. The fact is that we now have our three buildings and we're ready to begin moving to the next stage, which would be to manipulate how these buildings sit on the site and how they interact with one another.